Hey everybody, Eric Dorward here with the Spartan Rocketry Club for what is definitely the last video in the Estes Black Brant XII construction. Now, in the previous video, I mentioned that I need to balance it. There is an important step. We're listed right here in the instructions that say we need to find the center of gravity. And I just did that, but I'm going to show you how to do it, just so you know. So first things first, when you find the center of gravity, you want to put the heaviest motor you're likely to put into this thing. That's probably, for my sake, this is an F-15. So this is a 29 millimeter gunpowder motor. It's almost full, as you can see. There's still a little bit of space in this thing, but this is a big motor. It is surprisingly heavy. So I have fully assembled the rocket. Everything's in it, including the motor, you can see, is in the back end of this. Now, the instructions say the center of gravity can't be more than 38.69 inches. 0.69 inches, of course, just kind of silly, that it would be that precise. But somebody did this with a computer and found out precisely where the stability point, or the farthest out you can go with one of these things can be. So here's the rocket, at least the part that I can get in frame, because this thing is, almost as tall as I am. Anyway, to find the center of gravity, this is a fairly easy one. All you need to do is find the balance point. So I'm just going to put my finger and use it as like the balance point in a seesaw, and just keep moving it until I find the balance point. It's starting to come undone there. Anyway, it's pretty close to about here. Yeah, somewhere around there. All right, that's pretty good. I mean, it's still wobbling a little bit, but the balance point is somewhere around there. So here's what I did. I grabbed a fabric tape measure like this, and I measured starting where my balance point was, which is approximately here, and I stretched it out from there to the tip of the nose cone, and I have thoroughly tangled my tape. Oops. But in any event, I am stretching it out all the way to the nose cone, and oops, lost the handle of it. I end up, it's just around, let's see, straighten this out a little bit because I got a kink in it here, but anyway, it's right around 39 inches. 39 inches would be bad. I need it 38.69 or less. So in order to fix this, I need to move the balance point down the rocket that way. That means weight in the nose cone. Now, if you recall, there is still a part of this that can come off. It's right here. So I'm going to detach this, and the rest of the rocket is just going to go down for the moment. I've used all the clay that came with this, so I need some more. This stuff is just air dry clay that you could get at a craft store, pretty much. Actually, I don't really know. I'm pretty sure I got this at a craft store. Not entirely sure where you go other than that. It's not like you buy clay at the grocery store, but this is just, brown. Yeah, so I need to just get some of this stuff and put it in. Apparently, previous users of this have made some flat pieces here, so I'm just going to get a ball of it. And this is one of those things where, oops, this is actually kind of dried out. I should probably add a little bit of water to this, but I don't think that's super important. Typically, I would roll this out to a snake, but there's a good amount of stuff already in there. So in that goes. I'm going to use my dowel here, which hopefully will reach far enough. And yeah, so I am just going to push it in place just like I did with all the rest of the stuff. I'm not entirely sure how much clay I'm actually going to need to affect the, there we go, to affect the center of gravity. I need to move it at least half an inch. But of course, the offset is for every bit of clay in here, you're making it heavier, and therefore it's going to fly not as high. So it is kind of, it's a balance. I would say it says 0.69 inches. So as long as I get it around 38.5, center of gravity of 38.5, I'm going to be happy with that. I'm not going to feel like I need to get it down to about 38, because the truth is that the motor in here is the heaviest I'm ever going to put anything in it. It's an F. I would probably be more likely to use a composite motor, which I expect would actually be lighter. And I'm not going to put like a G composite motor in this, even though it could probably handle it, because I don't know, if I put a G in this, the likelihood of me getting it back I think is pretty low. So anyway, I'm going to go with 38.5 inches for a balance point. So let's find the new balance point. It seems to have shifted up a reasonable amount. Okay. That's pretty close. We'll say that this is the new balance point. All right. So again, grab my measuring tape. Now let's see how much that affected it. That pushed the center of gravity a little bit, but frankly not very much. So I'm probably going to have to put at least double the amount that I put in last time in order to get the center of gravity moved properly. Again, I'm not going to go completely wild here. I'm not going to, get it down to 38, because the likelihood that I really fly it on Fs isn't that high. Because according to this, if you put an F in this, this will clear 1,000 feet easy. And that's high. I mean, I have a chute release, which I don't generally use, which could probably make this workable, but I just don't fly things that high. So I think flying this on an E is probably about as high as it's ever really going to get. But still, I want to at least get within the instructions tolerances for safety. So anyway, again, ramming the clay down. This is going to be kind of a trial and error thing. If you don't want it to be a trial and error thing, then you might consider learning how to calculate how a rocket, what the stability factors are. And for a rocket like this, or pretty much every one, what you're looking for is the interplay between the center of pressure, which is, once you build the rocket, it's pretty static. It's based on the fins and the transitions and things like that. And you can learn how to calculate it by hand, or at least approximate that calculation if you want to. Or, what most people do, is go out and get some software and trust that the software is going to calculate it with sufficient accuracy for you. All right. Ooh. Oh, I can hear stuff rattling around. That's not reassuring. It means I did not get the clay properly seated in there. That's kind of a problem. Oh, yeah. Well, I see what got loose. It's a square piece that apparently I did not properly tamp down in there. If it's rattling around in there, it's not doing its job. I mean, having the weight forward of the center of gravity will help, but if it's not all the way in the nose cone, it's not being utilized properly. So that's better. All right. Reassembling this bit. Okay. Finding the balance point again. Hopefully I've shifted it. Oops. The transition here where the rocket comes apart is falling apart. Coming undone. Whoops. That I probably am going to have to put a little bit of masking tape on this transition to keep it straight. All right. There's my balance point. Now it's actually a little bit farther up than that. All right, so this is my balance point. Again, grab the tape and measure. Anyway, you could probably get the exact amount of clay that you need to add in here using good rocket software. But we're not going to get bent out of shape about that. All right, so now I actually moved, yeah, wow, I put enough clay in there to move it to 37 inches. That's more than I need. But that being said, I'm cutting into my altitude by having that extra clay, but I'm making it more stable, and I can live with that. It's going to be a royal pain to go fishing that clay out, so I am not going to worry about that. Also, I'm not 100% that my center of gravity, my balance point, is exactly where I have the tape, so we'll say this is good enough. Anyway, the final thing I need to do then is I need to put glue. And this thing is so big, it's unwieldy. I need to put glue right here to attach these two. Again, the instructions say epoxy. I'm going to use crazy glue instead. I'm going to put it on the inside of the cardboard part, and I want these two bits right here, the little wooden parts that we attached, I want them in line with each other. Now, that being said, I'm going to separate this rocket where transition, not the transition, where it comes apart, where it's supposed to come apart. So that way, this is a lot more manageable. Because I really, it's heavy enough as it is, and this isn't terribly easy. Here's hoping that my crazy glue. I have a feeling that I'm gonna have to clear up the hole again with my paper clip. Seems to be like a lifespan in these crazy glue bottles, where once you get past it every single time, you need to punch a hole in things. All right, so crazy glue, again, I'm going to put it in fairly far, so that way I can kind of like line everything up before I ram it home. And again, I am going to, this has to be quick, and I want the little wood parts to be in line, so they look pretty good. Oops. And on we go. All right, that looks, yeah, that looks pretty good. They are not perfect, but they are awfully close, and I would call that good enough. All right, that is the last thing that I needed to do to fully build this thing. I need to take the motor out. I need to repack everything. This wouldn't be the worst time, as I said, for a clear coat, but again, I don't trust putting the clear coat on the metallic paint, so I'm done. Hooray! This took months of real time. Thanks for watching. I will be moving on to whatever's next in the next video, so I will see you then.